morning, integrated topics students. Miss Codner here, talking to you on April the 6th lesson and also April the 7th. Almost done. Basically, what, a week and a couple of days, and then spring break. All right, so let's get started with this. So we definitely need pencil, calculator. The homework, if you did not already turn it in by the end of last class, I'll collect that. And also take out your notes from last class, because what we're going to do is just continue on. So that's why I said at the bottom, paper for notes. So first things first, we have a drill. So while I was collecting the homework, I just gave time for them to get the drill. And I want you to basically find the GCF. So last class we talked about factors, and we also talked about finding the GCF, which is short for greatest common factor. So we have for number 1, 18xy and 36x squared. Number 2 is 54 and 63. Number 3 is 15r squared and 70rs. And number 4, it's 24 and 81. So that last one should look familiar because it was also one of the problems from the previous homework. And it seemed like a lot of students had trouble with identifying the correct answer for this. So that's why I put it on today's drill. So after giving some time for them to work on the drill, and if you want, you can pause this and try to figure out what the solutions are to each of these problems. So after a time, I had students come up and just write their answers for their solutions. So say for the first one, we have 18xy. So I want to break down that 18. So I can say 9 times 2. Then I can break down that 9 with 3 times 3. So 3 is a prime number and 2 is a prime number. Okay? Then I have my xy. So if I wanted to write it, and I'll put it over here, for my 18xy, I have 2 times 3 times 3 times x times y. So now for the next one, 36, I can use 6 times 6. And then the 6's I can break down because they're composite numbers, which gives me 2 times 3 and 2 times 3. So for my 36x squared, if I put in numerical order, I have 2 times 2 times 3 times 3 times x times x. So if I'm trying to find the greatest common factor, I want to see what they both have in common. So I notice that they have a set of 2's in common, and they also have a set of 3's in common, and one set of x's. So if I'm trying to find my greatest common factor, I'm going to multiply the sets. So I'm not multiplying 2 times 2. No, I'm multiplying my first set of 2's times my second set of 3's times my third set of similar terms, which is x. So now, 2 times 3 gives me 6 times x gives me a total of 6x. So 6x is actually going to be my greatest common factor for number 1. For number 2, 54 and 63. So again, a lot of people are able to get or to understand what their greatest common factor is just by looking at it. So if you think 54, what 2 numbers multiplied together will give me 54? I can say 9 and 6, okay? And then 2 numbers to give me 63, wouldn't that be, what, 9 and 7? If I wanted to, I can break down my 9, which will give me 3 times 3, and then break down my 6, which gives me 3 times 2. So for the 54, I have 2 times 3 times 3 times 3. And then I'll do the same thing with the 63. I can break down this 9 with 3 times 3. But 7 is a prime number, so that's going to stay right where it is. So now I have 3 times 3 times 7. What do they have in common? They have one set of 3's in common and another set of 3's in common. So my greatest common factor is 3 times 3 because it's the 3 in that first set times the 3 in the second set, which gives me a total of 9. Okay? So hopefully you guys are seeing this. For number 3, we have 15r squared and 70rs. So for the 15, we can still do that factor tree, which will give me 5 times 3. And 5 is a prime number because I can't break that down other than 1 and 5. 3 is also a prime number, so I don't have to break that down. So far, with 15r squared, I have 3 times 5 times r times r. The reason why it's 2r is because of that square. Now the 70. I can say 10 times 7. With that 10 broken down will give me 5 times 2. Again, the 7 is a prime number. So far with 70 RS, I have 2 times 5 times 7 times R times S. So now, what do they have in common? They have 1 5 in common, and they have 1 R in common. So the greatest common factor is not going to be 5 times 5 because there is only one set of 5's that we circled that they have in common. And there's only one set of R's that they have in common. Okay, do you see where it's coming from? So now my GCF is 5R. So I'm not multiplying the 5's within the set. I'm just going to multiply set times a set. And lastly, so we have 24 and we have 81. So with the 24, again, I could do 6 times 4 if I wanted to. I could do 8 times 3. So with the 6's, I got 3 times 2. With the 4, I have 2 times 2. So far with the 24, if I put in numerical order, it's 2 times 2 times 2 times 3. Now, does it have to be in numerical order? It doesn't, because remember, it's multiplication. So multiplication is mostly associative. Then the next one is 81. So I can say 9 times 9. Now, if you use 1 times 81, guess what? You're still going to have to break down 81. So when you're doing the factor tree, try not to use 1 times itself. Again, the 9's can factor themselves out with 3 times 3. So for the 81, it'll be 3 times 3 times 3 times 3. What do they have in common? They have one set of those 3's in common. So since it's just one, that means the greatest common factor is 3. A lot of people told me 9 because I think they just try to mix it up. Say, okay, let me multiply that 3 times 3. But if it's within that set, you only have to write it down once. Okay? So that was the warm-up. And a lot of people were doing very well with that. Now we're slowly getting into what we finally want to do, which is factoring. So the best way that I can think of to introduce it is to think about your distributive property. So when you have your distributive property, we know that when we distribute, we multiply. So in this case, I'm going to distribute 4x to everything inside the parentheses. So now, 4x times 3x, that is 12x squared. The reason why that x is squared, because when we're multiply, remember, we add the exponents. So all that stuff that we learned earlier, that still carries over. And the reason why it's square, remember, those x's have a 1 as an exponent. Even though you don't see it, it's assumed to be there. So it's 1 plus 1, that's where that square came from. We have our plus sign, so we bring that down. 4x times 4 will give me 16x. So this will be my solution when I distribute. But what we're going to do is distributive property backwards. So think about Jeopardy. Jeopardy is a type of game that you're given the answer and you have to figure out the question, or you have to state that solution as a question. We're doing the same thing, and we're going to take what we learned about the greatest common factor to help us do distributive property backwards. Now let's think. Once I get my greatest common factor, which is 12 and 16, what will be the greatest common factor? So the greatest common factor is a number that goes both into 12 and 16. So I know a lot of people want to say 2 right off the bat. But is 2 the greatest? No. How about 4? 4 will work for 12 and it will also work for 16. So now, I have 2 x's here. I have 1x there. How many x's do they have in common? Hopefully you said 1. I want to know how many they have in common. If you said 3, that's how much they have in total. I don't want to know the total. I want to know what they have in common. So right now, 4x is my greatest common factor. So when we did the distributive property, we did multiplication, right? So now we're going to work it backwards. So what operation do you think we're going to do now? We're going to do division. So basically, we're going to divide my GCF with the original expression. Meaning, 12 divided by 4 will give me what? It will give me 3. X squared divided by our x in the greatest common factor would give me x. Why is that? Remember, when we're dividing, we're doing subtraction with our exponents. We have our plus sign, so we bring that down. And then we have 16 divided by 4, which gives me 4. And then x divided by x will actually give me 1. Because think about it. If we're subtracting the exponents, we have an exponent of 1 with both of these x's, right? So now we got 1 minus 1, which gives me 0. Anything raised to the 0 power is 1. So if I wanted to put that times 1 there, I could, but I don't have to. Okay? So then this would be my original question for this answer right up here. So what we're slowly getting into is called factoring. So factoring, as I said before, it's like you're given the answer and you have to figure out what the question is. So this is the title for today's notes, factoring. And the best way I'm going to do this is through examples, and I'm going to go through it step by step. If you think about this as a whole, you're going to get confused. So here's some steps that you want to take. So you definitely want to write these down for future reference. First step, find your GCF. What is your greatest common factor? Then you're going to divide the original expression with the greatest common factor. You're going to put that solution in the parentheses and make sure that your greatest common factor is in front of the parentheses. Okay? So again, if you want to pause it, you can pause it just to make sure you have these written down. So first thing, find the GCF. Second, divide the original expression with your GCF. Third, put that answer in parentheses. And fourth, put the GCF in front of the parentheses. All right, so let's go through some examples. So first one, we have 18c squared d squared plus 12c. So the first thing I should do is find my GCF. So what I also did in class is I showed you manually how to find your GCF. But today, I actually showed you how to find the GCF through the graphing calculator. Ooh, I know, exciting, right? Some people say it's faster, some people say it's not. Hey, it's up to you. So the way to do that is you type in your math button. And the math button is right underneath that green alpha button. What you're going to do is you're going to arrow over to where it says num. And num is just a short version of saying number. Okay? Once you get there, you're going to go to number 9, or you can type in number 9, and it will take you to what says GCD. And you're probably saying, well, Ms. Conner, aren't we dealing something with GCF? Yes. Greatest common factor is the same as saying greatest common denominator, okay? Or the greatest common divisor, okay? So many people had so many interpretations of it, but it's the same process, okay? What do they have in common? So for us right now, we have 18 and we have 12. So what you're going to do is, they already started off with a beginning parenthesis. You're going to type in 18, and you're going to have to put the comma in. And the comma is the button just above the number 7. Okay? So you have to put the comma in between because the calculator will not know the difference between 18 and 12 versus 1,812. Okay? So you're telling them you want to find the greatest common divisor of 18 and 12. You can close the parenthesis if you want, or you can leave it open. In this case, it doesn't matter. Once you do that, hit enter. Some people knew before we got started with this that their greatest common factor was going to be 6 with the numbers. This just basically clarified that step for us. Okay? Now, when you're using the graphing calculator, just as a warning, you can only do 2 numbers at a time. So if you're given a list of 3 or 4 numbers that you want to find the greatest common factor for, you can only do 2 at a time. So that's why I like to show you how to do it manually, and also how you can do it through the calculator. Okay? So my greatest common factor for the numbers only is 6. But now let's look at the variables. So here we have 2 C's. Here, I have 1c. How many c's do they have in common? Hopefully you said 1. Remember, you're thinking in common, not total. The other one, we have 2 d's here, but we don't have any d's here. So how many d's do those terms have in common? None. So right now, my greatest common factor is 6c. So that was that first step. So now here's the next step. We have to do what? We had to divide, right? So we got to divide the original with my GCF. So we can do it this way, or we could do it what we did for the example. But I like to do it this particular way because it forces me to do that division. So I'm literally going to put a division sign and 6c underneath both terms. So this is going to force me to do this division. So then here I go. I have 18 divided by 6, which gives me 3. I have c squared divided by c, which gives me c. Because remember, when we're dividing, we're subtracting the exponents. And since d squared is being divided by 1, really, I'm just going to bring down my d squared. There's a plus sign in between, correct? So we're going to bring that on down. And then we're going to do 12 divided by 6, which gives me 2. And then c divided by c is 1. So right here is going to be the factor of my original expression. Okay? So let's try the next one. So we have 15a squared minus 30. First things first, I need to figure out what my GCF is. So you can use that trick with the calculator. Go to math, then arrow over to num, hit number 9, and then type in 15, comma, which is just above 7, and then 30. Now, I notice there's a minus sign near the 30. If you put a negative number when you're trying to find the greatest common divisor, you will get an error. They can only do positive numbers. Okay? So you're just looking at the 15, you're just looking at the 30. So when you type that in, hopefully you got 15 for your greatest common factor. Now let's look at the variables. I have 2 A's here. I have no A's here. How many A's do they have in common? None. So my greatest common factor right now is just the 15. So now we're going to factor. And the best thing for me to do is, the next step, I got to divide everything by my 15. So 15 divided by 15 is 1. A squared divided by 1 is just a squared. You can write 1a squared, that's the same thing. There was a minus sign, so I'm bringing that minus sign down. And then 30 divided by 15 is not 15, it is 2. Okay, so then this right here is my factor of my original expression. Okay, let's try this one. So 14xy plus 18x squared y cubed. Same thing applies. If you want, you can pause it Try to work it out yourself, and then hit play and see what you get for an answer. We'll compare our answers. Go ahead, pause. Okay, so if you paused, what's my greatest common factor? With 14 and 18, they only have 2 in common. 14 has 1x, 18 has 2 x's. How many x's in common? 1. The 14 has 1 y, the 18 has 3 y's. How many y's in common? 1 y. So now we're going to fill in the parentheses. I'm going to divide my original by my GCF. So 14 divided by 2 is 7. X divided by x is 1. Y divided by y is 1. Okay? So I don't need to write any x's or y's down. Okay? I do have a plus sign. 18 divided by 2 is 9. X squared divided by x is x. Y cubed divided by y, remember you're subtracting, is y squared. That means this is my factor. Okay? And one more. So we have 2a cubed plus b squared plus 8ab plus 16a squared b cubed. I know right off the bat you're like, what is this? It's okay. Do the same exact thing. What number can 2, 8, and 16 have in common? The only number I can think of is 2. So for the 2, she has 3 A's. For the 8, there's 1 A. For the 16, there's 2 A's. That means they have 1 A in common. Then I have 2 B's, 1 B, and 3 B's. That means I have 1 B in common. So now I'm going to take my GCF and divide it by everything of the original. So 2a cubed b squared divided by 2ab will give me a squared b. Bring my plus sign down. 8ab divided by 2ab will give me positive 4. Bring down my plus sign. Remember the a's and the b's, they almost cancel out. 16a squared b cubed divided by 2ab will give me 8ab squared. And this is my factorization. Okay? So then, from here, I had them try 2 problems. Okay? Some classes they did. Some classes got it by the 3rd, so we skipped this part. But some classes they tried these 2 problems. So I would give these 2 a try if you want extra practice, but if you got it, fabulous. If you want to do it and just check your answers. So for the first one, I had a 8xy and 2 minus 5y as a solution. And for the other one, I have 3y times 4y squared plus 3y plus 9. Okay? So if you gave them a try, check your answers in mine. And if there's any complications, just check with me when you guys come back. So the last part is the homework. We had a total of 4 problems, just like last time. You do the homework, you turn it in, everything's fabulous. Okay? After or while a lot of students were doing the homework and turning it in, Before you know it, it's getting ready for final examination time. So for students that had me before, I want to explain what the final exam project is. So what the final exam project, the final exam, they get a packet of 8 problems before final exams. Okay, it's very similar to what I did for midterms. And what happens during the final exam time, I have a panel of 2 teachers or 2 educators that will come in and help critique or help judge, I guess, um, how the students explain their answers to one of those 8 problems. So what they'll do is they'll do the 8 problems ahead of time. One of the panelists will say, okay, I want you to do problem number 4. So that student will turn to problem number 4, put their paper underneath the document camera, and proceed to explain how they got their answer. Okay, it's very similar to what I did for the midterms. That's one part of the final exam. The other part is going to consist of students doing a PowerPoint presentation based on a potential career. So the things that I have listed below, students are really going to need to copy these things down. The career description. So they're going to give me a brief description. Trust me, bullet points are your best friend. Just give me a brief description about the career that they're thinking about pursuing. They're also going to tell me the benefits and the limitations to that career. So the benefits could be making more money, having enough power if they want to be an entrepreneur. They can say, I can make my own hours, I can sell what I want to sell, what have you. Some of the limitations, like we all know, is if we do any kind of job, we have to deal with the public. So you have to deal with the public's issues, got to deal with their, got to be satisfied. The customer's always right mentality. Okay, so sometimes that's a limitation. The other thing I would like to see is how are they going to make that career a reality? So there's some careers that, yes, I have to get certification. Yes, I have to take some coursework in college. But what type of coursework do you have to take? What type of lessons that you have to get certified in? And what is the cutoff? How does someone know that, hey, you're the person to get because you scored a certain level of certification? Do you have to take an internship? If you have to take an internship, how long do you have to be in this internship before you can actually branch out on your own? So it's a lot of those detailed things, and this might require a little bit of research, okay? And if, as I said before in the classes, was if they've done something similar to this within their other classes, they can use that same information for this. All they have to do is just composite all that onto PowerPoint slides. The next part is the mathematical connection to their career. So there is math in everything. It's just a matter for the student to figure out where is that math. And then lastly, I want them to develop a mathematical example. So let's say they want to be an architect. Where's the math in architecture? Obviously the angles, the measurements, and I really want them to come up with a scenario. Say Johnny wants a building to be so tall, so wide, and I want them to actually do the math behind it. Okay, so that's how I'm tying the math into this whole career work. So as you can see, it's like basically 6 topics up here. The career description, benefits, limitations, how to make it a reality, the mathematical connection, and actually a math example. So I'm looking at roughly 6, maybe 7 slides. If they want to go higher than that, that's fine. Is it going to make their grade go higher? I'm looking more so at quality, not so much quantity. Okay? So I don't want to just throw a slide in there. Oh yeah, I'm going to get an A because I have 20 slides. I mean, the whole presentation should take no longer than 5 minutes. And that's including their explanation of one of the problems from the packet. Okay? What I did give was just to help guide them through their thought process. I'm trying to do this a little bit at a time because I don't know if other classes are going to give you projects before the end of the school year. So I don't want you to be bombarded, but I want to make it clear, so I'm making a statement here, that if you don't do the little steps, guess what? You are going to get overwhelmed towards the end of the school year. I don't want that to happen. So please, just write down your career title, where I have career written, and then just write down some benefits and write down some limitations. Do I want you to fill all these spaces up? No. If you only have 2 benefits and you have 3 limitations, so be it. If you have 5 benefits and 3 limitations, so be it. It's up to what you think the benefits and the limitations are. So just to start out, think of a career that you want to do. And one of the things that I forgot to do is, let me see if I can put it up here. I had a couple examples from last year's group. Okay, so this one was from TJ. He was so excited when I said I'm going to use him. So he wanted to be an athletic therapist and just gave me a brief description of the career. Also gave me some benefits, gave me a couple limitations, how he's going to make the career reality. Even though there's some bullet points up here, he was still explaining each step. Even though he says years of study in college, he verbalized what he would have to take in college. How long would he have to be there? You know, okay, years of observing and job shadowing. I think he told me like about 1.5 years up to 2 years, all depending on where he's stationed at. I'm like, okay. But he was able to verbalize a lot of this. Where's the math? He gave us a couple examples where the math is. And for his display, he actually wrapped someone's wrist, okay, just for the display portion. Another one was game designing. I know a lot of kids love this. Okay, so I had this person do a little bit of sound effects, gave me a little bit of information. Now, love the graphics, but if the graphics overpower the verbiage, it's going to be tough for you to read, okay? Also, the career reality, he explained a lot of this. And where's the math? He actually showed us something separate because he didn't want to ruin the picture, which was hilarious to me. But anyway, welcome to my world. All right, another one. It's my girl Mel. Okay. So this was good. She told me a little description of the biology. My suggestion with this would be not so many bullet points because a couple of them could have been just verbalized. Notice she had the pros and the cons. Pros and cons are similar to benefits and limitations. And she had it on one slide, and that's perfectly fine as well. How she made it reality, okay, math and psychology. But the only thing that was different from last year's to this year is I want you to come up with an example. And let's go one more. Okay, so hopefully this gives you an idea of what I'm kind of looking for. Okay, notice that the graphics, not totally overpowering. Okay, yeah, we could have cleaned this up a little bit with more just bullet points. Okay, so that's what I'm generally looking for. Okay, my computer's freaking out, but that's okay. But that's generally what I'm looking for when it comes to the final exam. I'm going to try to do a lot of this in class, okay? So we don't have to go running over here. I don't have a computer at home, blah, 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 blah. You're here, okay? We have computers in the school building. Eventually, we're going to get our laptops back once the HSAs are over. and we'll be able to apply all this. If there's any questions or any concerns, please don't hesitate to contact me, or please don't hesitate to come during Wildcat Hour, okay? We're going to have all this stuff right here. But definitely start thinking, start writing, and write some steps out step by step, okay? Any questions, any concerns? Don't hesitate to contact